Good day, everyone. We are here to discuss to you the local and global wind system. But first, let me introduce my group mates. Yours truly, Mia Vel Araos, Miss Karil Lucas, and Miss Leslie Fernandez. So, what is a wind system? Wind systems are large-scale atmospheric circulation driven by uneven heating of the Earth, leading to the movement of air from high to low pressure areas and influencing weather patterns and ocean currents.
So what is global wind system? Global wind systems are big patterns of wind that moves around the earth. These winds are affected by the earth's rotation and the way the sun hits different parts of the planet. The main types of winds in these systems are trade winds, westerlies, and the polar easterlies. The trade winds blow from about 30 degrees latitude towards the equator. They move to the west as they go towards the equator because of the Earth's rotation. These winds are very steady and have been used by the sailors for a long time to travel across the oceans. The westerlies blow from west to east and are found between 30 degrees and 60 degrees latitude. These winds affect the weather in places like United States, bringing rain and snow. Westerlies are important for the weather in many parts of the world. The polar easterlies blow from the poles to 60 degrees latitude. These winds are cold and move away from the poles. In the northern hemisphere, they can bring cold Arctic air to places like the United States, causing snows and freezing weather. Polar easterlies are important for the climate in polar regions. So these winds belts help shape the weather and climate around the world.
Local wind systems are small-scale air movement driven by localized differences in air pressure, primarily caused by uneven heating and cooling of the Earth's surface and influenced by topography. Unlike global wind patterns, these winds operate within a relatively confined areas. Example of this is the sea breeze or land breeze cycle. During the day, land heats faster than the sea, causing warm air to rise and cooler denser air from the sea to flow inland as a sea breeze. At night, the land cools more rapidly, reversing the process with cooler air flowing from land to sea as land breeze. In mountainous regions, valley and mountain breeze prevail. During the day, sunlight hits mountain slopes, creating warm air that rises as a valley breeze. At night, the slopes cool and denser. Cold air descends into the valley as a mountain breeze. Chinook or foehn winds are another example, where warm, dry air descends the leeward side of a mountain range after losing moisture on the windward side. Furthermore, katabatic winds are strong, gravity-driven flows of cold, denser air down slopes common in polar regions, while anabatic winds describe the general upslope movement of air during the day. The strength and direction of these winds are influenced by the magnitude of temperature differences and to a lesser extent. The Coriolis effect for larger local system. These local winds contribute significantly to the formation of microclimates, small areas with distinct climate characteristics.
To conclude, local wind systems driven by temperature differences across surfaces are key to shaping weather patterns and microclimates. These winds, such as sea and land breezes, valley and mountain breezes, and katabatic and anabatic winds, regulate local temperature and humidity. These winds play a crucial role in defining regional climates and essential to understanding local meteorology. In global wind systems, shaped by Earth's rotation and the sun's heating, significantly influence weather and climate. Trade winds, westerlies, and polar easterlies create distinct wind belts that impact regional weather, ocean navigation, precipitation, and temperature. These systems regulate global climate patterns and contribute to the Earth's diverse climates.